Hello, and thank you for joining this talk today. My name is Schormann. I am a program manager working on the Azure Digital Twins platform, and that is what I want to talk about today. There's a lot of buzz today around the term digital twin, yet not everybody agrees with what the term actually means. Broadly speaking, a digital twin is a digital replica of some selected aspect of real-world things, places, business processes, or people. Usually it is designed to help us understand, control, simulate, analyze, and improve real-world business operations. Azure Digital Twins is Microsoft's development platform for next-generation IoT solutions that are based on modeling aspects of a real-world environment. We'll go into details of what we mean by that. Using the power of IoT, we have connected and monitored individual assets and machines for quite some time now. IoT has made it possible to bridge the gap between design models and real-world products, improving both the products and the customer experiences. And this really often involves multiple types of digital twins. For example, digital twins of factory lines are intended to improve the operation of the factory, but many customers also have started building digital twins of each product they make and ship. And these product twins really can help designers and manufacturers to gain a lifetime view of their products, literally from the drawing board to past the recycling bin. In the coming phases of digital twins, we will take all these capabilities of a digital twins environment beyond engineering optimization and beyond assets and enable customers to create very rich models of entire business environments and eventually even networks of businesses in a very holistic manner. And this new generation of digital twins will combine traditional business data with a comprehensive model of many different aspects of reality in one single pane of glass as one transparent model of a business that can drive operations, analytics, and simulation. But today, modeling and creating connected environments is still quite challenging, even for a sophisticated business. That brings us to Azure Digital Twins. Azure Digital Twins is a developer platform for next-generation IoT solutions that model the real world. After being in preview for the last few months, I am really excited to say that the service has just reached general availability. So why digital twins? Let's talk about an example. So a commercial building manager traditionally knows really little about the actual use of the building. And as a result, it is quite difficult to manage everything from energy consumption, so the heating and cooling in the building, to space utilization efficiently. That matters, especially in a world of global warming, given that energy usage of buildings is responsible for somewhere between 30 and 40% of all global emissions. Equipping buildings with a bunch of sensors to enable data-driven decisions really seems like a good idea. But as it turns out, raw IoT data is not all that interesting and informative. To make sense of it, we need context information. We need to know what place a given sensor is measuring, where it's located, what other sensors are around it, what other values need to be aggregated together with that sensor value and correlated to it, and so on and so forth. And we typically also need a lot of external business information to make sense of the data that the sensors provide. Perhaps even more importantly, as a building manager, I don't really care about sensor readings. What I really want to know is which spaces in my building are comfortable, how much the different spaces are utilized, how satisfied the tenants are with the waiting time for the elevators, how efficient my HVAC system operates. In short, I want business answers to business questions. So customers really want to reason about the world in terms that match their understanding of that world. And this is really important. I really want a software solution that describes the world in terms that make sense to me and that I do understand. So what we need is a scalable design pattern that allows customers to create software models that represent their real worlds. The buildings, floors, rooms, HVAC systems, and so forth for a building manager, or the power stations, transmission lines, and substations for energy grids, or farms, stables, and maybe even cows for a farming solution. A core goal for Azure Digital Twins is to allow developers to focus on adding business value and differentiation for their business instead of having to worry about building and operating complex distributed systems infrastructure at scale. Azure Digital Twins is built around 4 core elements. First, there's the ability to model your perspective of the real world using an open modeling language. Then we have an execution environment that is brought to life with data from IoT sensors using a built-in event-driven data processing system to make sense of the data and to extract insight from it. And then we have rich input and output connectivity that lets you connect Azure Digital Twins both to input sources and that lets you send data on to downstream services and other places where you either want to store, process, or analyze the data. We will look at all these elements in more detail in a moment. As I mentioned earlier, there are many different aspects of reality that a digital twin solution can choose to model. The focus of Azure Digital Twins is a topological or structural representation of an environment. You can think of this as a knowledge graph that can represent semantic relationships of many kinds, including, for example, organizational relationships, usage or workflow, dependencies, spatial relationships. Combined with a powerful engine to ingress, process, and query real-time state data from IoT and other data sources, this approach can provide very rich contextualization of environmental data, orchestrate data processing, and power a lot of insight generation. Another important aspect of reality that a digital twin might choose is 3D geometry, as for example in Bentley's iTwin project. Understanding the geometry of an environment opens the door to many other dimensions of insight. Or another take on environmental geometry is provided by maps and the specific views and capabilities that you get in map views of an environment. To mention just one other aspect of reality, customers are also increasingly developing an appetite to accurately model behavior aspects of the environment, for example, driven by physics simulation. Azure Digital Twins is ready to drive federation of these and many other representations of reality for a comprehensive digital twin solution. We will talk about that in the context of Bentley's iTwin in a moment. As we said earlier, real-world environments in ADT are modeled as a topology graph. The entities that make up the graph are called twins, and each type of twin is described as a collection of properties, telemetry, commands, relationships, and components. At the heart, really, of the graph building are relationships. Relationships define how individual twins can be connected to other twins in order to make up that knowledge graph. You really can think of relationships as the verbs between the nouns. So if the nouns represent the entities you model, like, for example, a building, a floor, a factory line, a machine, or any other concept or physical thing that you want to model, then the verbs represent the type of semantic relationship between them. For example, a building has a floor, an HVAC system cools a particular neighborhood, or an air compressor in a factory is billed to a particular customer. Relationships also can have properties which gives extra richness in the knowledge graph that you construct. Twin definitions are expressed in DTDL. That is a simple language based on JSON-LD and RDF, but it basically gives you a much easier way to author these things without having to know anything of the underlying technology. You see a real simple example here at the right. It's effectively basically a JSON file that represents a model. Once you have defined your custom business vocabulary in ADT, you can create a graph of twins. So typically customers will do this programmatically, driving the topology with data that is already available in other databases, for example, a building information management system, or in the case of Bentley, in Bentley's iTwin system. In ADT, all data changes generate events. Incoming telemetry, property changes to the graph, creation or deletion of twins or of relationships, all that results in events that custom business logic can react to. Developers can define event handlers for processing events within the graph and propagate data through the graph, for example, to create aggregates or to normalize data or to generate insight by applying a machine learning model or whatever is needed to be done. ADT also provides a real powerful query system that lets you extract insight from your modeled environment. Developers can feed the graph with data from external sources such as IoT Hub. IoT Hub is an IoT platform component that provides rich management and deployment facilities for IoT devices, making it easy to set up and control complex device configurations. IoT Hub connects easily to ADT to drive device data into the service. Using the ADT REST APIs, you can feed ADT with data sources other than IoT. It's also possible to create a connector for logic apps or other services that can wrap REST APIs. Logic apps in particular provide a great low-code or no-code platform for access to ADT. Developers can also define event routes that send selected data out from ADT to downstream services. Supported endpoints include things like event hubs, event grids, or service bus, all the components you need to handle messages at scale to other services. Examples for connections include, for example, cold storage, Azure Data Lake, machine learning systems, other analytics with Azure Synapse, or workflow integration with logic apps, many other things. Also very, very important is integration with time series insight that can be used to track data over time and apply historian analytics. As I mentioned before, Azure Digital Twins is a developer platform. That is, there are no UI components that face end customers. Digital Twins really comes in form of APIs for developers. Think of it as a model component in the sense of a model view controller pattern that developers can use to drive any number of views, such as, for example, maps or data overlays on 3D models or traditional dashboards with traditional controls. It is a PaaS offering, a platform as a service offering with a pay-as-you-go scheme, and it's controlled using a rich set of REST APIs. In addition, there are language-specific SDKs available for better developer comfort and for developers to efficiently access and use the models defined in the Digital Twins definition language. There's a parser library that validates and reflects over DTDL. And this allows developers to really easily create model-driven user interfaces or model-driven processing, which is a real nice way to develop against the system. Let us briefly look at just a couple of use cases. Azure Digital Twins is already used in multiple business domains across the world. Edge Technologies, for example, is a developer that uses Azure Digital Twins internally as a platform that powers a new generation of very cool, unusual commercial buildings that are designed to be really healthy for humans and sustainable for the environment. And behind that sustainability promise and the comfort of the building lies a smart building software platform that is built on Azure Digital Twins. Visata is a completely different domain. They are an ISV that builds systems that are not run by Visata itself, but that are run by the customer. And Visata provides a platform for manufacturing automation and optimization that is built, again, on top of Digital Twins, where Digital Twins handles the data communication and the data modeling, and Visata added an AI platform and a data exploration capability to the mix. Bosch Building Technologies provides solutions and services for commercial buildings. The software solution is based on Azure Digital Twins, and it's a great showcase for the power of semantic modeling in generating insight from raw data. Willow, another ISV, leverage Azure Digital Twins to deploy Willow Twin, which is really a software as a service offering that does real estate and infrastructure project management. Willow Twins enables owners and operators of real-world assets to reduce costs, improve operational efficiency, and better engage, like their occupants. In addition to customers, at Microsoft, we really very strongly believe that comprehensive digital twin solutions are a partner play, where products from multiple vendors together provide a solution that is more than the sum of the parts. To this end, we are also part of the new Digital Twins Consortium as a founding member, where we are working with other partners on establishing best practices, definitions, and design patterns and solutions for digital twins in many domains. As part of this talk, I would like to highlight two of the partners we are working with, ANSYS and, of course, Bentley Systems. Physics-based simulation has long been a very essential part of the product design process to help engineers to optimize and validate design choices before the products are actually built. So with the broad deployment of IoT sensors in products and their environment, it is now possible to apply these same simulation technologies and techniques that have been so successful in product design after a product has been built, shipped, and deployed in the field. And simulation technology can then be used to optimize performance, energy usage, or failure prediction in really accurate and immediate ways without the complexities that are associated with alternative techniques. ANSYS is the market leader in technical simulation software. ANSYS Twin Builder lets engineers quickly deliver real-time simulation models for operational use. And with Microsoft's Azure Digital Twin platform, it is then possible to efficiently integrate these simulation-based twins that simulate the behavior of a specific machine or a specific part of the environment into a broader system-wide IoT solution. Bentley. In the world of infrastructure development, complex CAD data is the backbone of planning, execution, and operation of infrastructure. Bentley's iTwin platform captures all the rich geometry and all the metadata of the project and its environment as the source of truth that drives daily decision throughout the entire life cycle of the project. You can kind of like think as a developer of iTwin as GitHub for CAD data. Using Azure Digital Twins, we can now bring this backbone to life using all the raw and processed information from IoT sensors that are distributed throughout the infrastructure. And by bringing this wide range of information sources together into a comprehensive digital twins, including CAD data, real-world scans and photometry, IoT sensor data, weather feeds, and many, many more, we can really revolutionize the way infrastructure projects are planned, built, and operated. So let's have a look at this in a video that we have created that shows a proof of concept solution for infrastructure management built on top of Azure Digital Twins and Bentley iTwin.
Welcome to the Civil Operations demo. This is a collaboration between Microsoft and Bentley. This project showcases a powerful integration of Bentley's iTwin technology with Microsoft's Azure Digital Twins. And what this is a web app that allows us to view a roadway in Australia. It's called the Coffs Harbour Roadway, which is outside the town of Coffs Harbour. It's a 25-kilometer roadway, and we're going to hook it up to the Internet of Things and view live data of all the assets throughout that road. All right, let's take a look at our web app. You can see over here, there's a view of the Coffs Harbour town, and we need to look for our roadway. So in order to do that, we're going to turn up the transparency, and you can see right here the model that we're working with. So let's go ahead and take a closer look. We'll zoom in and rotate, and you can see that the roadway is made up of several different elements. So we have different asset types. As you can see to the left, we have bridges, tunnels, and roads. And all these assets have their individual sensors connected to them that help determine the overall health of that asset. For example, let's take a look at the bridge. You can see that it has this vibration and deflection sensor. Get one of the tunnels. You can see it's got a bunch of sensors. We have air quality, temperature, then we also have cameras in case there's some issue that arises, and we can hopefully get a view on site on what's going on in that tunnel. Then we have roadways. In the road segments, we have the vehicle counter that helps determine the congestion on the road. And again, we have a camera in case there are any issues that show up. Okay, so now that we have an understanding of the different sensor and assets, let's go ahead and turn on the live data. You'll see this pop up. What this means is we're signing in to get access to our ADT instance. Once you're logged in, you will see that the colors are changing for these assets. So you can already see the yellow and the green. What that is the overall health of that asset. Yellow means that it's getting worse. Green is perfectly healthy. And we can take a deeper dive. So let's click on, for example, this tunnel. You can see all the different sensors. And if you hover over one of the sensors, you can see the actual data, the latest data in the ADT instance that's stored, the CO and the NO2 values. And you can see they're changing too. So this is live data that we're currently streaming in from ADT. Let's give it a second, watch it change some values. You can see as the temperature goes yellow, the entire asset turns yellow. So it always picks out the worst case scenario based on all the different calculations, values it's getting. Okay, so far you've only seen the green and the yellow, which are both acceptable values. That means that there's no problem really, just fluctuating health of all these assets. So what happens when we actually have a situation? So let's simulate a crisis and see what that would look like. Oh, wow. So there it is, just in time, code red on T1SB. So when we click on that, let's see what's going on. You can see that the asset has turned red. That means we need to look into it like right now. And we have the sensor, the culprit sensor. You can see the CO values, they've gone about 2 to 3 times of what they were before. So this is a problem. And we have the camera. So maybe there's some hints that we can get on what might be going on here. So you click on that, click show image. And oh, wow, so there's an accident. And because of that, there's likely congestion in the tunnel. At this point, if I were the operator, I would either dial in, or hopefully this app has a feature in the future where I can turn up the ventilation for this tunnel and rescue the passengers from the crisis. So where does the data come from? This scary diagram shows everything you need to know about how the data flows. There are 2 types of data here. On the top is a live data that comes from the sensors, and the bottom is the iTwin model that includes the 3D geometry for the tunnels, bridges, and roads. Let's talk about that one first, since that's where we actually start. Infrastructure engineering data is often modeled using multiple applications. We can take these various formats and run them through what we call a bridge to transform them into a single cloud-ready iModel format. In this case, the data was originally modeled using our civil engineering applications, OpenBridge and OpenRoads Designer. Over here, you can see the bridge pushing the actual data from design files into an iModel on iModel Hub. If you don't know what the iModel Hub is, it's a cloud service for centralizing and managing infrastructure projects. Great, so once our data is on the hub, we can visualize it using an iTwin viewer. This viewer allows us to enrich the model with data from other sources, such as Bentley's Reality Data Service, Microsoft's Bing Maps, and even Azure Digital Twin. And that's exactly what we did for our demo. We customized this viewer to add those data connections and change asset colors based on sensor data that was coming in. One last thing here, how do we connect the bottom data to the top data? We use a cloud agent that generates DTDL formatted data from the iModel, which is then used to create the instance of our Azure Digital Twin. Now that we have our iModel and ADT instance in place, we are ready to talk about where the live data comes from. The story starts all the way back in the simulation service on Azure. It has a bunch of different devices that you saw in the model, and it generates telemetry information for those devices. And the way we define them is we can define each individual sensor type. For example, this is the air sensor, air quality sensor. You can see the NO2 values and the CO value, and we have a minimum and maximum and a unit. And we're passing all those values out. And this is hooked up to the IoT hub, where we have a unique ID to identify each individual device that's listed in the IoT devices blade under our IoT hub instance. This is then hooked up to an Azure function, which takes in all this telemetry information and computes the overall health of a higher level asset, such as a tunnel. And you can see that happening live right here. So these are the values, and this is the values being written. And finally, while this function writes in all this information, this is hooked up to an instance of the time series data, and that gives us the historic values of everything that goes on within our model. So for example, I captured the same event here where we had the crisis. You can see this is the air quality sensor, and you can see the value of it spike up. and you can see the health of the tunnel 1, and see the value spike up as well as it goes out of bounds above 100 is when we see the red and we are in trouble. And that's what we started with in our model. So that's the story of how the data goes all the way from our simulation service into our app in real time.
With that, we're at the end of this talk. And so let me just summarize a few key takeaways. Digital twins are an important component of next-generation business solutions and connected environments. Azure Digital Twins is your development platform for next-generation IoT solutions. It is built around the ability to model your perspective of the real world. It provides an execution environment brought to life with data from IoT sensors and other sources and accessible with powerful queries. It offers an event-driven approach to data processing and flexible connections to the outside world. It is well suited to integrate additional aspects of digital twins, such as, for example, CAD geometry via Bentley iTwin and behavioral simulation into a next-generation operational business solution. Thank you very much for listening.